Let's compare linked lists and arrays to understand why we'd choose one over the other. Let's go back to our analogies. Array, a row of fixed-size lockers, numbered 0, 1, 2, etc. Each locker holds one item, and you can jump to any locker instantly using its number. Linked list, a treasure hunt where each clue leads to the next, but you have to follow the path step by step. Key differences. Memory allocation. Arrays use contiguous memory. All lockers are side by side. Fixed size, so adding more items may require a new, bigger array. Linked lists use non-contiguous memory. Nodes can be anywhere in memory, linked by pointers. Dynamic size. Add or remove nodes easily. Access time. Arrays. 1. For accessing an element, for example. Array 5 is instant. Linked lists. N. For accessing an element. Traverse from head to the desired node. Insertion/deletion. Array. Insert/delete at end. If space exists, 1. Insert/delete in middle. N. Shift elements to make space or fill gaps. Linked list. Insert/delete at beginning. 1. Insert/delete in middle or end. N. Traverse to the position. Memory usage. Arrays, fixed size, may waste space if not fully used. Linked lists uses extra memory for pointers, next, and previous in doubly linked list. Use cases. Arrays, great when you need fast access by index or know the size in advance, for example, storing a fixed list of scores. Linked lists, ideal for frequent insertions/deletions or when size is unknown, for example, a playlist where songs are added/removed dynamically. Example scenario. Imagine managing a playlist. Array. If you have 10 songs and want to add an 11th, you might need a new array, copying all songs. Removing a song in the middle requires shifting others. Linked list. Add a song by linking a new node. Fast at the start, slower at the end. Remove a song by adjusting pointers, no shifting needed. Does this comparison make sense? Want to discuss a specific scenario where linked lists shine over arrays? In summary, linked lists sacrifice access speed for flexibility in size and insertions. Arrays sacrifice flexibility for fast access. Common mistakes beginners make with linked lists. As a beginner, linked lists can be tricky because of pointers. Let's go over some common mistakes and how to avoid them, so you don't trip up when working with linked lists. Forgetting to update the head. When you add or remove a node at the beginning, always update the head pointer. If you forget, you might lose the entire list. For example, if you add a new node but don't set the head to point to it, you'll still be pointing to the old head, and your new node will be lost. Not handling the empty list. If your linked list is empty, head is null, and you try to delete a node or traverse, your code might crash. Always check if the head is null before performing operations. In our code example, we handled this by starting with an empty list, but it's a good habit to add checks. Losing track of pointers when deleting. When deleting a node, make sure to update the pointers correctly. For example, if you delete 5 from 3, 5, 10, you need to set 3's next pointer to 10. If you don't, you might end up with a broken link or a memory leak. Not setting the last nodes next to null. When you add a node at the end, ensure its next pointer is null. If you forget, your list might accidentally point to some random memory, causing errors when you traverse. These mistakes are super common, but with practice, you'll get the hang of managing pointers. Want to go back to our code and add some checks to avoid these errors? Wow, we've covered a lot. Let's see what we learned. Basics. Linked lists are chains of nodes with data and next pointers, starting at the head. Analogy. A treasure hunt where each clue links to the next. Why use them? Linked lists are flexible for dynamic sizes and easy insertions/deletions. Operations, insertion, deletion, traversal, search, reverse, and cycle detection, with time complexities like O1 for head operations and ON for others. Coding. We wrote a simple linked list in Python to add and print nodes. Comparison. Linked lists are dynamic and flexible compared to arrays' fixed, contiguous nature. Mistakes to avoid. Watch out for pointer errors and empty list cases. Challenges. You practiced building and modifying your own linked list. Advanced. We touched on doubly and circular linked lists, plus problems like merging or finding the middle. Now, let's look at real-world applications. Playlists. Music apps use linked lists to manage song queues, easily adding or removing tracks. Browser history. Doubly linked lists track forward and backward navigation. Undo functionality. Text editors use linked lists to store actions for undo or redo. Operating systems. Linked lists manage process queues or memory blocks. That was all for today's session. You nailed it. Great job. Keep practicing with the challenges, and soon you'll be a linked list pro.